Hi, welcome to this video. My name's David Edwards. In this video we're going to look at some of the general features of a soil profile. We're doing this indoors using these profiles that have been collected and made up as what we call monoliths, but a lot of what I talk about today could apply equally to whether you dug up a profile and had that exposed naturally outdoors as part of your field work. Make sure that when you've got your soil profile and you've actually dug a hole and it's exposed, it should look like this, where you've got it very well exposed and the main features are quite obvious. Typically we want it well lit, the profile, so we can actually easily describe the features that we see and the type of properties that are important as part of the profile itself. But we also want to make sure that it's not in an awkward position. So again, we obviously make sure we don't have ants' nests or something like that in the middle of where we're working here. Now, as part of this first stage of thinking about how we describe the soil profile, the main thing is to think about, well, what are the general features of the profile that we can talk about? So what are the general properties that tell us something as to why this soil looks different to any of these other soils? So typically some of those things are obvious to you just looking at it now. That would be things such as soil colour, perhaps the different types of boundaries and breaks within the soil, perhaps some idea of how much you have thicker versus slightly less thick or thinner layers within the soil as well. So, generally speaking, we should always make at least some distinction about how many layers we can see, and that will be based upon typically colour is the thing that guides us firstly, but also things such as the properties and feel of the soil. Is there obvious features of different grain size? So is it maybe sandy in one bit and a lot more clay rich in another layer? But also we might think about whether there's maybe more organic rich layers. Again, colour will very much give us a guide on how to actually determine where those breaks would be. Now, when it comes to describing the properties of a soil profile and trying to understand why they vary and how they vary in some way, we should remember that the soil itself is part of the surrounding landscape. And so therefore we should consider those surrounding landscape features as part of our soil profile description as well. So when you collect soil, you've hopefully made some notes upon those surrounding features that you see in the landscape where the soil is being formed. Remember also that many of the features we see in the soil, we will typically relate back to the 5 factors of soil formation. And hopefully you've had some lessons on that already or done some reading on that. So remember the 5 factors. We normally remember them through the little initials of CLORPT, C-L-O-R-P-T, CLORPT. So CL stands for climate, and so there's some obvious things there about hot versus cold climates, wet versus dry, and hopefully you'll appreciate by now that climate drives most changes in environmental systems, is one of the key drivers in actually making environmental systems look different around the world. The O stands for organisms, and so a biotic factor. So obviously thinking about whether there's any small amounts of material that have changes in the soil material that we see here through, say, tree roots, the accumulation of organic matter, maybe the turning over of the material through burrowing organisms, a whole range of things related to the organic component. R is actually the relief factor. We could also think of this as a topographic factor as well. So that the R stands for, the topographic factor stands for whereabouts in the landscape are we here? Are we on top of a hill or down the bottom of a valley? And that's going to make some big differences in the soil profile as well. P is for the parent material. So what type of rocks or material has the soil formed from? Has it formed from a sedimentary rock? Has it formed from material that's already been reworked and maybe then laid down by a river? Has it formed on igneous rocks, so rocks produced from volcanic origin? So the different geology and the different settings of where the parent material can form, a sand dune versus, say, the edge of a river, those things will be important in determining soil properties. And of course the last one, of course, will be time. And obviously to get a well-developed soil profile like these, we need a lot of time to differentiate the various layers and have all the processes that work within the soil actually do that differentiation for us. You may describe the profile in the field, but typically what we'll probably be doing here, certainly in many of the undergraduate labs as well, is you'll take some samples and we can come back and describe those samples in the classroom. So the questions then arise, where will we take the samples from? And again, we will be looking at things like whether there's some obvious boundaries or breaks within these soil profiles. But in addition, we'd be thinking about, well, you know, how many samples is enough to adequately describe one particular layer versus another. So again, we may actually go off the breaks that we can see, the obvious breaks and boundaries, but sometimes the breaks will be subtle, or they'll be chemical boundaries and we don't quite see them as much, or we need specific lab tests to actually show where those breaks are. The main thing to remember here when sampling the soil is that soil, of course, is measured from the surface down. So if we're measuring with a tape measure, and you may see some tape measures in the film here as well, but they've been stuck on as a guide. But the main thing to appreciate is that we always work out where the surface is. So I'll use the one over here on the right-hand side where it's actually got a little bit of organic matter on top and so forth. And so if this was the surface of the soil, we'd make sure our tape measure was aligned to that surface, and we'd stake that in some way and then measure down in depths. So remember, with depths below the surface is what we're measuring. Typically, a lot of the topsoil layers may only be in that top 10, 15, 20 centimetres or so. And we may actually choose to sample the top layer and the sub-layer of the topsoil material. So you can see here it's a subtle change. You can see it's definitely darker in the topsoil material and definitely lighter down here. And very little change in the red one over here that we can see. Others is a much more abrupt change where you can see the darker grey versus the more pale colours here versus the more yellow colours with depth. If the layers are more than 10 centimetres thick is the general rule, and so for example this middle layer here is only in the order of around 10 centimetres or so thick, so you can see here that's 10 and the layer ends here in that order of around 15 centimetres thick. So maybe one's enough for that pale layer there, and typically the layer above it. But certainly if it runs for maybe 20, 30 centimetres, such as the much more yellow layer down here, we really should be doing samples perhaps every 10 centimetres apart. So at that stage, we actually may have multiple samples and we need to make sure these things are fairly clearly labelled in some way. Here's an example of a sample that we've taken on one of our field trips. You can see it's actually labelled here. So the MP, so it's in a nice secure bag, good quality bag here. Madden's Plains, so it's our first site, so MP is written on the bag. It's the top 5 centimetres and we've dated when we've taken the sample from. Now that's actually quite a large sample and you may not take that much. So we've had to think about the general features of the soil. What can we see? How many layers do we think we can see? Colour's going to guide us a heck of a lot, but there may be other features that are obvious as well. We're going to look at things like colour and also pH and texture in other videos that will appear as part of this group of videos on soil description. So that concludes this video. There'll be some questions there to make you test your understanding on the elements that have been covered in this video. So make sure you complete those and then move on and look at the other videos in the sequence.